curve sketching example. Basically, we're going to throw everything we've got at this function about our knowledge of functions and calculus and everything we got to try and graph this thing. So the first thing I think we want to do is, because if we take the derivative of this with just the power rule, we'll be left with a cubic. And I'm not interested in factoring cubics, so I think maybe we can try and do this without. Maybe there's another technique. So let's pull out an x. So x cubed minus 12x squared plus 48x minus 64. Okay, if you've learned binomial expansion, you should recognize this to be 4 cubed, and this is an x cubed, and these pieces here, you see x is decreasing by 1. Anyways, you should be able to see pretty quickly that's x minus 4 cubed. Granted, you don't have to know how to factor cubics, but when it is a nice expansion like that, you should be able to recognize it. Okay, so that's f of x. Now, instead of using the power rule to take the derivative, we can use the product rule, and things will stay factored, which will be nice to see when things are equal to 0. All right, so f prime of x is first times the derivative of the second, which is 3x minus 4 squared, plus the second times the derivative of the first, which is 1. If we take out an x minus 4 squared, we should have 3x plus 1. Is that right? 3 first derivative of the second plus 1. Oh, sorry. No, never mind. Almost made a mistake. We still have an x minus 4 here. So x minus 4 and the 1. Yeah. All right. So if we simplify this a little bit, we get x minus 4 squared and then 4x minus 4. Okay. And now let's take that's f prime. Let's take the second derivative, and then we can just graph everything all together. So f double prime of x equals first derivative of the second. Oops, sorry. I don't know how that happened. First derivative of the second, x minus 4 squared derivative of the second, plus the second derivative of the first, which is 2. Jeez. Which is 2 x minus 4. All right, same situation. We've got some x minus 4s. So x minus 4 times x minus 4x minus, I'll be left with 1 for x minus 4, so that'll be 4x minus 16. And then that x minus 4 has been taken out, but we'll have plus 8x minus 8. Okay, so then we get x minus 4. Don't know why that's doing that. X minus 4 and x minus 4 and what is that? 12x minus 24. All right. So intercepts first. If I plug in 0 for this whole thing, to find the y-intercept, I get 0. Okay. If I plug in 0 for y, I'll just do it here. 0 for y, I get 0, obviously, and 4. So it touches out here at 4. Okay. Also, so now let's do some increasing, decreasing. So there's a 0 slope at 1. If I plug in 1 here, I get 4 minus 4, which is 0. And there's also a 0 slope at 4. So there's a 0 slope there. Oh my gosh. 4, 0 slope here, and at 1. There's a 0 slope. I don't know where it is. We have to find that out later. All right, so f prime, 0, 1, and 4. we'll just pick a half. If I plug in a half here, I get that's positive, and plug in a half right here. Half of 4 is 2, minus 4 is negative. So from 0 to 1, it's going down. If I plug in, let's see, 2, I would say 2, that's positive because of the squared, and that's positive. 8 minus 4 is positive. So positive times a positive is positive. So it's going down and then up, which would create a minimum. And then if I put in 5, positive, positive. Okay, but where is that minimum? Well, let's just plug in 1 here. We get 1 minus 4, which is minus 3, cubed, which is minus 27, times 1, still minus 27. So minus 27. So there's the minimum. Okay, let's do some f double prime stuff here. F double prime. You see that there's a 0 inflection. No, I can't say that. The f double prime is equal to 0 at 4, right here. And it's also equal to 0 at 2. So if I plug in 2 here. So f double prime, 2 and 4. If I plug in the inflection at 1, that's negative right here, and also negative. So that would be negative times a negative is a positive. So the inflection is positive. It's an up bowl shape at 1. And it's only changing at 4 and 2. Okay, if I plug in 3, well, if I plug in 4, how about that? Plug in 4. No, I'll plug in 3. Plug in 3, I get negative. And plug in 3 here, I get positive. So that's negative. Positive times negative is negative. And if I plug in 5, positive, positive. Okay, so the inflection is looking like, I'll do the graph in green. There's a minimum here. It's a concave up bowl shape, a concave up all the way till 2. So there's your point of inflection. This thing's driving me crazy. Okay, point of inflection to 2. And then it's down bowl from 2 to 4. Goes through right there at 4, and it's up bowl after that. And there, ladies and gentlemen, is curve sketching.